So now let's talk about some other properties of proportions. There are four in all. We've just learned the cross products property of proportions. So here are the other three. The reciprocal property of proportions. In a proportion, the reciprocal of one ratio is equivalent to the reciprocal of the other ratio. So mathematically that looks like this. If A over B is equal to C over D, then B over A is equal to D over C. Now it's extremely important to note here that none of these numbers can equal 0. Because if any of these numbers equal 0, then we end up dividing by 0, and that never works. Division by 0 is undefined. Proving this one is actually quite easy. We'll just use the cross products property of proportion to say that AD is equal to CB. And then if we divide both sides by A and divide both sides by C, we end up with B over A is equal to C over D. We have the means exchange property of proportions. In a proportion, exchanging the mean of one ratio with the mean of the other ratio will result in a true proportion. Namely, if we have A over B equals C over D, then A over C is equal to B over D. To prove this one, it's just a matter of using the multiplication property of equality to multiply both sides by B, and then using the division property of equality to divide both sides by C. Voila! A over C is equal to B over D. And finally, the property that I like to call the numerator-denominator sum property of proportions. In a proportion, adding the denominator of each ratio to the corresponding numerator will result in a true proportion. In other words, if A over B is equal to C over D, then A plus B over B is equal to C plus D over D. To prove this one, all that we have to do is add 1 to both sides of the equation. The trick is, whenever we're working with ratios, we get to choose what that 1 looks like. So on the left-hand side of the equation, I'm going to make 1 look like B over B. And on the right-hand side of the equation, I'm going to make 1 be D divided by D. Then when you add ratios, you add the numerators and keep the denominators. So we end up with A plus B over B and C plus D over D. Interestingly enough, if you subtracted 1 from both sides of the equation, you would get something similar. So this works with subtraction too. Quick example. Given the ratio x over 8 is equal to y over 9, what ratio completes the equivalent proportion x over y equals blank over blank? Well, let's take a look and see what has happened here. Notice that the y has moved from the numerator on one side to the denominator on the other side of the equation. Wait a minute. The top right-hand side is a mean, and I've moved that mean down to where the other mean belongs. Oh, I'm exchanging the means in this problem, aren't I? So therefore, x over y is going to equal 8 over 9, the means exchange property of proportions. So the trick to these types of problems is to identify which property of proportions you're using and then rewrite the proportion.